Hello, everybody, and welcome to another video lesson. In today's video, we're going to walk through a program that checks if a mathematical expression is balanced. What this means is that we're going to be focusing on making sure that the parentheses inputted by the user for an expression are properly matched and nested. This is a key concept when we're working with expressions in programming, making sure that everything's balanced, everything makes sense. And then we're going to use a stack to help us do this efficiently. So our goal for this program is going to be to take a mathematical expression as an input from the user and check if that expression is valid. The user's expression is going to contain things like integers and operators like addition, subtraction, multiplication, division, parentheses. Our task is then to check if the parentheses in the expression are properly balanced. If the expression is balanced, we'll output your expression is balanced, and if it's not, we're going to output your expression is not balanced. And it's worth mentioning that a fully robust expression checker is going to go beyond just parentheses. For example, it would make sure that there's an operator between every pair of integers, that operators aren't duplicated, and that the overall structure follows like basic mathematical rules. But for now, we're just going to focus on balanced parentheses, just one small but important part of validating the expression. But before diving into the code, we are going to review some concepts of stacks, which we learned about last week in this program. So we've learned about stacks, and we know that they're a data structure that works on the principles of last in, first out, or LIFO. I think some people say LIFO too, but I think I've heard most people say LIFO, so use that. This means that the last item added to the stack is going to be the first one that gets removed. In this program, we're going to create a custom stack class called charStack, CharStack, to manage the parentheses. We'll push opening parentheses onto the stack and pop them off when we get closing parentheses. So I'm going to quickly construct our custom stack, the header and implementation file, and I'll walk you through a basic review of what everything does. Okay, so first things first, I have Visual Studio Code opened, and I have a folder that I'm working in the workspace of called stack balancing, stacks equation balancing. So it'd be advantageous for you to do the same if you're following along. Make sure that you're working in a folder so you don't have all of your solution files kind of just scattered to the wind. Just a recommendation. So I'm going to create a new file, and I said that we're going to call this charStack. And again, it's the name of a class should start with a capital letter. So I know that when we do camel case, you guys normally see things like this, but when we're creating like classes, it is customary to capitalize the first letter of the name of the class, and you can use camel case. We mostly use it in the class for everything else. So I'm going to say charstack.h. So I'm going to start with my header file. And it says, you want to save it here? And I said, yes. There's some new stuff here. There was some update on some of the extensions that I use that take care of IntelliSense and things like that in Visual Studio Code. So please ignore this. I'll find a way to turn it off soon enough, but the update was relatively new. So I want to start with my guards. So I'll say if in def, and then underscore charStack, and I'll say hashtag define. This can be a little bit of a pain, can't it? So I just want to make sure to include these so that the file isn't included more than one time when we're doing the compilation. So that's in case you were wondering. And then I'm going to close it as well. Hashtag. And then I like to say what it is. It's charStack. Okay. And I wanted to declare a constant here, and we will call it const int max stack equals 100. And what we're doing here is, so we're defining our constant to limit the size of the stack. Remember, this is an array-based stack, so we have to explicitly say how big this is going to be. And that was kind of one of the advantages of some of the dynamically sized data structures that we learned, like we learned linked lists the other week. The benefit of that is you don't have to do things like this. You can just add things, and the data structure dynamically resizes with arrays. One of the drawbacks is we have to say, all right, this is how big it's going to be before we can continue with it. Okay, so that's not too bad. It's just something to keep in mind. Let's go ahead and start our class declaration. Car stack. And then before I forget, I want to put a semicolon at the end for proper syntax. And I'm going to save. I want you guys to save your work as well. Okay, and we're going to have some private member variables. So I'll go ahead and I'll use the keyword private. Oh, that's my dog. She heard something and is going to go investigate. So I'll say private and put the colons and then say what it is. And we will say of type char, items, and then the size. Oops. And a variable, an integer variable, to keep track of the top index of the stack. So we're going to have this character array called items. It's going to hold the contents of the stack. And that's what this is doing. And we always want to keep track of the index of the top element in the stack. Okay. And I also want to have some public member variables and public functions. So we need our constructor, the default constructor. I usually label it just to kind of reinforce with everybody what it is. And then bool is empty. Okay. So we have our constructor. We have a method to check if the stack is empty, and that's what this is going to do. Okay, so we also have other operations that are associated with stacks, push, pop, and peek. So we'll go ahead and declare those now. Void push const new entry, and then we will have void pop. We will have a return type of a character, and we will call it peek. And we have const, and I'm just double checking to make sure that everything looks good. I'm going to save. And at this point, I just want to address why we're using the const keyword in the isEmpty method. So the const applies to the method itself. It means that the method isEmpty does not modify any of the member variables of the class. We're just confirming that, and we're telling the compiler and the person who's reading the code, that calling the isEmpty method is a read-only operation, meaning that it's just going to check the stack's current state and doesn't change anything. And this is important because we want to establish that these methods are not intended to change anything. So that's why that's important. And I wanted to also establish this here, because maybe this syntax again is a little bit new for us, but you're using const char with the ampersand instead of just char, and you're doing this because you're passing the character by reference, and you're marking it with the const keyword to say it's not going to be modified inside of the function. So the reason why we're using char and then the ampersand is because in this specific case, since char is a very small primitive type, it's just 1 byte, passing by reference doesn't save memory or performance. In fact, it might even be slightly less efficient. So in practice, you can omit const and the ampersand, but because we want to make sure, we want to convey that this isn't to be modified, we're going to use it this way. Yeah, just thought that I would clarify that because the syntax is a little bit more. So if we avoided using const character with the little ampersand, it's fast, but it's not as fast as if we didn't do it. And we're just making sure that this is a read-only modifiability. Okay, all right, so so that's going to be it for the header file. Let's go ahead and make the implementation file. So we're going to spell it the same way, and we're going to put the CPP extension. Okay. And the first thing I wanted to do was I want to include some necessary libraries. So hashtag include, and then we're going to use, I want to put the space here. No, I don't. I'm trying to be consistent. CAssert. CAssert is going to be used for runtime assertions, and then we're going to do our IO stream. We're going to also include our header file here, and we use parentheses for that. Okay, and I think that should be good. We want to use the namespace. Whoops. Some of the IntelliSense stuff kind of messes me up sometimes. I'm pretty sure it messes you guys up too sometimes. Okay, but we can start, let me save this. We can start looking at what we need to define. Okay, so I have some of these. I have a constructor, some variables here. Okay. So we're going to define our constructor, and it has lots of parentheses, and top equals -1. So our constructor initializes top to -1, which is going to convey that the stack is empty. And this is just like a common trick when using arrays to implement stacks. So you'll see this more and more. But this is what our class constructor is going to do. Okay, and I'm going to save this and look at the rest. We have is empty, push, pop, and peek. So void, name of our class, 2 colons, push, and it takes a const car address, new entry. Okay, and we want to check, or we want to, sorry, not check. We want to push something onto the stack. So this function adds a new character to the top of the stack. So we're going to start this by saying if top less than max stack -1. Whoops. We're going to increase the index of top by 1 because we've added an item, and items, the index at that location is whatever the user put, whatever the new entry is. So the push function, like I said, adds a new character to the top of the stack. We want it to first check whether the stack is full. If it's not, it's going to increment top, insert the new entry at that position. And you're probably asking yourself, why is there no else clause here? If the stack is full, we're just going to have it silently do nothing. And we can improve on this if we want to, and you can improve on this if you want to. This is a very basic implementation. So I'll go ahead and I will continue. Let's do these in order. So right here, I'll go ahead and I'll do the here stack is empty, const keyword. Let me double check here. Yeah, okay. And is this spelled right? Is empty? It's kind of getting mad. Yeah, it's fine. Okay, and then we're going to say return top less than 0. Hold on. I'm having something going on here. It's kind of getting mad. Declaration. Oh, that's why. It's a bool. And I had it as void. So I'll save this. This should solve it. So all this is doing is it's going to return true if the stack is empty. And we know it's empty because if top is less than 0, then it's empty. So we have everything, I think, addressed in order. So we have our constructor, the method that tells us whether or not the stack is empty, a way to push things onto the stack, and now it's time to write a way to pop things from the stack, to remove. So we're going to say void, and this doesn't return anything. Pop. Oops. Oh geez, life is made easier with these shortcuts, but it's also sometimes a little bit inconvenient. Okay, so with pop, we're going to remove the top item by decrementing the top. If the stack is empty, we're going to print a message to show us that we can't pop anything from the stack. So to do this, we're going to say if call this method is empty. So we're calling a method, and the method is empty, which we defined here. If it's not true, that's what this little explanation point does. So this is not. So if it's not empty, decrement top by 1, else we're going to say cout stack is empty, cannot pop. And then I'm just counting my little parentheses here and making sure everything's lined up. And that should take care of the pop method. We also have to write a function that peeks. So kind of shows, it's going to return a character. It's going to show us what's at the top of the stack. So that's what peek does. Okay, so let's define it here. It return type car. Peek has the const keyword after, indicating we do not want this method to change anything. Assert is empty. I'll talk about this in a moment. Okay. So with peek, again, we want to return the top character without removing it. We're using assert to make sure that the stack is not empty. So this is just an additional way to like insulate our code and make it less error prone. If it is, the program's going to crash with an error. And this enforces the precondition that peek should only be called on a non-empty stack. So I'm going to put a little note here that this enforces the precondition that the stack is not empty. And then I want to return whatever is at the top of the stack. And that's what that line does. Okay, I'm going to save. This should do it for our implementation of the char stack class. So we have our header file, and now we have our implementation file. Okay, so now we can work on our source.cpp. we can now start working on the main part of our code that's going to do the parentheses checking for the user expression. So let's go ahead and create a new file, and we will call it source.cpp. Okay, and we're going to include, we're going to start by including the necessary header files, and we're going to use IOStream for input and output, and string for handling strings. So let's go ahead and start with that. IOStream, hashtag include string, and then we want to include our header file, making sure to spell everything correctly, and we want to be in the namespace. And this is going to make it so that we don't have to keep doing std : in front of everything. So let's go ahead and say main, and then return 0, just boilerplate standard stuff. Okay, so let's go ahead and press enter here. This car stack pointer, we're going to call it a stack PRT equals new, and I'll explain this in a moment. Okay, so first we declare a pointer to character char stack. I keep wanting to say the full name, which is character stack. I'll just say the full name. To the character stack object called stack pointer, PRT, abbreviated. So here we're creating a pointer to a new instance of the character stack. What we're doing here specifically is we're dynamically allocating memory for the stack, I almost said snack, which is not necessary, but useful if you want to practice pointers and dynamic memory, which we do want to do. This stack will be used to store the parentheses as we process the expression. So that's what we're doing here. And we're going to create a string variable called user expression that's going to store the expression that the user puts. And we're going to say int length. We're going to have a variable keep track of the length of the user expression, and a Boolean variable called evaluated that we want to instantiate as false. So we use evaluated to track whether or not we've evaluated the expression to see if it was balanced or not, and we're going to use this in the code. So again, we have a variable, a string variable to store whatever the user expression is. We have an integer variable called length to, we want to loop over however many characters are part of the string. So we're going to store, that's what this is going to do. It's going to store however long the user string is. And then we have a Boolean variable to check whether or not we've already evaluated the expression as true or false. Okay, we can continue from here with our output. And we're going to say enter a math expression with parentheses. And so we're going to prompt the user to enter a mathematical expression. We want them to use parentheses in it so we can check everything. And then we're going to use getLine. User expression. Oops. And we're going to use getLine to read the entire expression. This allows us to capture the input, even if it has spaces in it, just that whole line, whatever the user puts. Okay. And then we want to get the length of whatever the user put. So the length of the string that the user inputted. So user expression dot length. So we're going to use that built-in function for the strings, to get the length of whatever the user put. Okay, so now that we have the user input, we're going to start traversing through each character in the input and looking for parentheses. So I'm going to press enter, enter, and we're going to say traverse through the expression string. And we want to do this for as many characters there are in the user string. So I start at 0, I less than whatever the length is, I increases by 1 each time as we move on to the next character in the string. So we're going to say, let's think for a minute. So we're looking specifically for parentheses. In this case, we're going to start with the case that the user enters an opening parentheses, or the character that we're on is an opening parentheses. So again, we don't need to store everything that we're evaluating, only the opening parentheses. In the evaluation process, we don't care what the operators or integers inputted by the user are. We only care that every opening parentheses has a closed parentheses. And this is the criteria we're using to determine whether or not an expression is balanced. So if the current character is an opening parentheses, push it onto the stack. And saving this is going to ensure that we're keeping track of the unmatched opening parentheses. So let's go ahead and push it onto the stack. So we're going to say if user expression I is an opening parenthesis. Oh, that really wanted to automate that for me. Hold on. Okay. Let's see. Stack PRT operation push user expression. So whatever the opening parentheses is. So if the character we're on is an opening parenthesis, push it onto the stack. That's what this is. Next, we're going to write the condition of if the character that we're on is a closing parentheses. So I'm going to say else if user expression I is a closing parenthesis. Okay, here's what we're going to do. So we have to cover for a couple scenarios here. So if the current character is a closing parentheses, we need to check if the stack is empty. If the stack is empty, it means that there is no matching opening parentheses for this closing parentheses, and the expression is definitely not balanced. So let's go ahead and write that out. So if, and then condition stack is empty, so we're going to call that method. And if that is evaluated to be true, then let's write a note here just so we don't forget. Extra closing parens scenario. So if this happens, this is the scenario we're dealing with. 1 second, make sure that's good. If that happens, let's tell the user that that's what's happening. And we're going to say your expression is not balanced. And no need for that. So in this case, let's just immediately print that the expression is not balanced. And then we're going to have to break out of the loop at this point because we've already answered the question. The expression is balanced. There's no need to continue looping through whatever the user put because the criteria for imbalance only requires that one parenthesis is missing. Doesn't matter how many parentheses are missing. If it's at least one, it's already not balanced. So in that case, we can say evaluated is now true. So we've evaluated the problem and we're going to break. Okay, and we need to write the next scenario, which is going to be there's at least one opening parenthesis on the stack. So to do this, we will say else if, hold on, I need to be consistent. If I'm putting else ifs after each closing curly brace, then I'm just going to keep doing that. So else if our variable that's keeping track of the stack is empty. So if there is something on it, okay, this tells us that there is at least one opening parens on the stack. Okay, so if this happens, we are going to PRT, and we're going to do the pop operation. I'm saving right there. So if the stack's not empty, we pop the top item from the stack. This is going to remove the matched opening parentheses for the closing parentheses we encountered. If you're kind of wondering to yourself, just because the stack is empty, the stack has something on it, how do we know it's a opening parenthesis? Well, we only have been adding opening parentheses. Nothing else is going to be added to the stack besides opening parentheses. So if the stack is not empty, then it means there's an opening parenthesis on it. And in this case, we're going to pop it because this is the method that we're using to keep track of opening and closing parentheses. So that's how we're doing it. Okay, that's going to conclude the loop. So I'm going to write, well, I could actually just copy this. And this is just so that because we have so many parentheses in this, we want to keep track of what goes with what, and this closing parentheses ends our for loop. So after we processed all of the characters in the expression, we need to check if the stack is empty. It's our final check. If the stack is empty, it means that all of the opening parentheses have been properly matched with closing parentheses, because every time we came across the closing parentheses, we popped a matching opening parentheses. This means that the stack should be empty, and if it is, then it's balanced. So this is our final check. So we're going to say if stack PRT is empty is true. And remember, we have a variable that's keeping track of whether or not we evaluated if it was balanced or not within the loop, the for loop. False. Then we're going to output your expression is balanced. Endl. Okay. So if the stack is not empty, that means that there's still unmatched opening parentheses left over in the stack. So the expression is not balanced, and we'll write that one next. So right now, this is what happens if it is balanced. But if there's still something on the stack, it's not balanced. So we're going to write the condition for that. Else if stack PRT is empty is not true, it's false, and we haven't evaluated this yet. Let's make sure that there is sufficient spacing here. Oops, I almost forgot. And some opening and closing parentheses there. Then we're going to output your expression is not balanced. Okay. And so if the stack is empty, unmatched opening parentheses somewhere or other, and then I'm going to actually just put an end line here just to make our output clean. And I'm going to get rid of some of the extra spacing here. I'm going to save. And that should conclude the main logic of our code. Okay, I ran it and it didn't compile. I mean, it compiled, it didn't run effectively, and I figured out why, and it's because I didn't do this. So I just put false, like assuming that the program's going to know what I mean. I mean, if evaluated is false. So I'll go ahead and I'll save this, and I will try, yeah, because over here, the run was unsuccessful, nothing happened, and the program kind of just ended. So if I compile it again, and if I run it again, I will say 3 plus 1 times 2. There we go. Your expression is balanced. That's going to do it for this video lesson. To sum it up, the program uses a stack to manage the opening parentheses in an expression and ensures that each closing parentheses has a matching opening parenthesis, and if all the parentheses are properly match and nested, the expression is balanced. So that's going to be all for this lecture. So we've walked through how to check if the equation's balanced, and in next week's lesson, we're going to build on this code. So keep an eye out for that. Thank you so much for listening, and have a wonderful day.